Welcome back to the deep dive. Today we are absolutely tackling a challenge that, a lot of you have brought to us. Understanding the architectural DNA of VMware Cloud Foundation, or VCF. You asked for a shortcut, really.
Right.
Not just what it does, but why it has the constraints it does, and also where it makes some surprising concessions for real-world complexity.
That is exactly right. And our source material today is, it's highly distilled. It comes from the core knowledge base you need to build and operate these environments at scale.
So these are the non-negotiable facts.
Absolutely. Think of it as, the stuff established under the pressure of real architectural scrutiny. We're going to skip the basic definitions today and just dive straight into the foundational rules that govern VCF design, security, and operation.
So our mission is pretty clear then. We're extracting the fundamental architectural principles of VCF, and we're going to organize them around, I guess, one central tension.
What's that?
The trade-off between strict standardization, which is really VCF's core promise, and the flexibility you actually need to run enterprise workloads. So where does VCF draw that line?
And we're going to see that line drawn very clearly in three main areas. First, establishing the rigid foundations, then defining the rules for storage and scaling.
Okay.
And finally, how you manage the whole environment centrally through the SDDC manager.
Okay, let's unpack this. I want to start with the very first brick in the wall. You can't have VCF without first standing up the management domain.
Right.
So what are the mandatory auto-deployed components that Cloud Builder forces you to deploy from day one?
So when you look at that management domain bring up, and that's, the critical moment where VCF establishes its control plane.
It's the beginning of everything.
It is. It mandates two specific core services. And these aren't like optional features you can skip. They are intrinsic to the very definition of a standardized software-defined data center.
And I'm guessing those two pillars are the vCenter server and the NSX manager cluster.
Precisely. The vCenter server is deployed first because, well, it's still the universal foundation for host management for lifecycle operations.
Sure.
And it's what connects the underlying infrastructure to the SDDC manager. It's the standard host controller.
And the second one, the NSX manager cluster, that's where the software-defined part really kicks in. So why is that mandatory for every single VCF deployment? Even if you weren't planning on doing complex microsegmentation right away.
Because VCF doesn't just manage VMs. It manages network policy and traffic routing across the entire stack.
The whole thing.
The whole thing.
Yeah.
That NSX manager cluster gets deployed to be the immediate control and management layer for all VCF networking. That includes crucial system traffic and all the overlay networks that the components themselves use.
Okay.
Without that NSX manager cluster, the fabric just isn't software defined, and the VCF automation tools, they just can't function. It's the networking brain of the architecture.
Speaking of the brain, let's define the key operator here. You mentioned the SDDC manager earlier. For anyone listening who might be new to VCF, can you just clarify its role compared to, say, vCenter?
Sure. The SDDC manager is the orchestration engine. It's the central control plane for lifecycle management and automation.
So vCenter is doing one thing.
Right. Think of vCenter as managing the hosts and VMs, but the SDDC manager manages the entire fabric.
Wow.
It deploys new domains, commissions hosts, runs updates, manages credentials, and ensures compliance. It is the centralized administrator of the standardized cloud, and we'll see how crucial it is later for security.
That distinction is key. Now let's pivot a bit to how architects categorize the rules of the platform. This is less about components and more about required outcomes.
This is a classic architectural hurdle. You have to differentiate between what a system must do
Right.
and how well it must perform or survive. We saw a great example in the source material. It said, the platform must be able to sustain the failure of one complete availability zone without manual intervention.
That's a massive requirement. I guess that's a functional requirement, right? Describing a core capability.
And that is the subtle but absolutely critical trap. It is not a functional requirement.
Oh, okay.
An FR defines a feature like, the system must encrypt network traffic. This requirement, it defines the level of service required, the guaranteed uptime, the resilience standard.
I see.
So architects classify this as a non-functional requirement, or NFR, specifically related to availability.
That makes perfect sense. It dictates the quality of the resilience, not the mechanism itself. For instance, the FR might be the system uses vSphere high availability.
Right.
But the NFR is that HA has to let us survive a whole zone failure with no human intervention. That distinction must drive some major design decisions like stretch domains or replication strategies.
Absolutely. So now we move into that central tension we talked about. How far does VCF let an enterprise stray from the pure VSN model?
Good question.
Because, VCF is often synonymous with hyper-converged infrastructure using DSAN. But enterprise needs are,
Ugh.
they're messy.
Right. So if you're building a new VI workload domain, the cloud where all your user apps live, are you locked into vSAN forever? And this is where VCF shows some surprising flexibility.
The key takeaway is that when you're provisioning those VI workload domains, while VSN is the standard, fiber channel storage is explicitly supported.
Wait, what?
And not just supported, it's allowed to be used as the principal storage.
That is a huge concession. Why would VCF, which is all about standardization and HCI, let customers plug into, specialized external SAN arrays?
It's purely practical. This flexibility is supported specifically to accommodate legacy, mission-critical, or specialized workloads. Think of large Oracle or SAP databases.
Okay, things that have their own dependencies.
Exactly. They have inherent performance or compliance needs that rely on traditional SAN fabrics. These apps might require specific zoning, low latency guarantees, or special snapshot capabilities that traditional FC providers just excel at.
I see.
VCF lets you standardize the management layer, the SDDC manager, while letting the workload dictate the storage foundation it needs.
So VCF is basically saying, look, we'll standardize the orchestration and compute, but we won't stop you from running your most sensitive apps on your specialized fiber channel arrays. That flexibility makes it way more viable in big, established enterprises.
Now let's flip that back to constraint. When we're using vSAN in a workload domain and we need to scale up, what's the minimum expansion unit?
Right. In the past, adding capacity meant adding racks of 3 or 4 hosts just to maintain redundancy.
Yeah, that was painful.
But the constraint here is much more operationally friendly. When you're scaling out an existing vSAN cluster in VCF, the minimum number of hosts you have to add is just one.
Just one host.
Eureka.
VCF enforces the configuration, of course, making sure that single host meets the standard baseline image and profile. But since VSN inherently supports incremental single-node capacity expansion, VCF respects that. And that is a massive win for administrators who need to expand capacity bit by bit without wasting capital on unnecessary hosts.
So it's standardization working for you for operational efficiency. Okay, moving on to connectivity. VCF's software-defined network, NSX, it needs to advertise routes to the physical top-of-rack switches, especially for the application virtual networks, or AVNs.
AVNs are so crucial here. They are the isolated virtual networks used by the infrastructure components themselves.
Like VLIs or vCenter.
Yes. So to get traffic out of the NSX overlay and into the physical world, the NSX edge nodes have to dynamically exchange routing information with the physical switches.
And that dynamic exchange demands 2 specific protocols. What are they?
The sources confirm that the physical network has to be configured to peer with the NSX edge nodes using either OSPF, which is Open Shortest Path First, or BGP Border Gateway Protocol.
Why those 2 specifically?
Well, BGP is really the industrial strengths choice. It gives you superior scalability, robust policy enforcement, complex route filtering. It's generally preferred for large, multi-site VCF deployments where you need fine-grained control.
And OSPF.
OSPF is supported for its simplicity in smaller environments and its fast convergence. It gives you that dynamic route advertisement and multipath resiliency you need. Both are valid, but BGP tends to be the standard recommendation at scale.
Okay, so if connectivity is about enabling flow, then validation is about preventing future pain.
Good way to put it.
Before any host, physical or virtual, can become part of the VCF fabric, it has to pass the commission host's workflow from the SDDC manager. What are the mandatory pre-checks that this orchestration engine performs?
What's fascinating here is that the SDDC manager is incredibly strict, and that's because VCF just can't tolerate ambiguity.
Okay.
It performs 2 critical validations. The first one is obvious. Network connectivity between the SDDC manager and the host management IP.
Can I talk to the host?
Can I talk to the host? Simple enough. But the second one, this one speaks volumes about the rigor VCF demands, and it's where most network admins run into issues.
And that is?
The second mandatory validation is for DNS forward and reverse lookup for that host. If the DNS records are not perfect, if the forward lookup doesn't resolve to the IP, or the reverse lookup doesn't resolve back to the exact name, the host commissioning fails immediately.
Why is VCF so militant about DNS? That seems extreme.
It's the foundational rule of any large-scale automated enterprise architecture.
Mhm.
VCF components rely entirely on name resolution for host identity, for licensing, certificate issuance, you name it,
So everything.
everything. If you allow a host with a salty DNS record to join, the environment becomes a ticking time bomb. Months later, during an automated update, the SDDC manager won't be able to properly identify or communicate with that host, and the entire maintenance workflow fails. Checking DNS upfront saves immense operational pain down the line.
That really reinforces the whole idea that standardization requires perfect infrastructure inputs, no garbage in.
None. Now let's talk about the centralized role of the SDDC manager as the administrator in charge. It moves way beyond initial deployment and becomes the single point of control for security and maintenance.
Security is always the biggest point of friction in large environments. Credential rotation is often a manual, painful process. The SDDC manager promises to take that on.
It does.
So our sources specify 3 absolutely critical infrastructure accounts whose passwords are managed and rotated directly by the SDDC manager. Who are they?
This is huge for compliance. The SDDC manager handles the ESXi root account,
Okay, the big one.
the vCenter server administrator at vSphere.local, and the NSX manager admin account.
That is a huge operational relief. We're talking about managing the highest privilege account for the hosts, the vCenter environment, and the entire networking plane all from one dashboard.
Exactly. This centralization ensures consistent, strong security policies and rotation cycles across the core infrastructure. I mean, if you had to manually manage the ESXi root password across 50 hosts and then update vCenter and NSX separately,
It'd be a nightmare.
the overhead would be astronomical. VCF manages this for you. It guarantees security uniformity.
And that same centralization applies to identity validation, specifically certificates. Which component is the single point of contact for managing and replacing CA-signed certificates for all those core parts? vCenter, NSX, the SDDC manager itself.
That functionality is consolidated entirely within the SDDC manager.
Of course it is.
It serves as the centralized interface for requesting, replacing, and managing all those crucial CA-signed certificates. Again, it's making sure your entire SDDC boundary is operating under a unified, trusted identity framework.
Standardization also applies to updates, even when, connectivity is limited. For environments disconnected from the internet, what we call dark sites, admins can't just click download.
Right. They have to transfer the update bundles manually.
So if an administrator needs to download those update bundles on an internet-connected machine for secure transfer later, they need a specific utility to prepare the package correctly. What's that utility called?
It's the bundle transfer utility. It's usually called by its command line name, LCM, Bundle Transfer Util.
That's a very specific tool. So it's not just a file transfer. It's about standardizing the update package format.
Yes. The tool is essential because it doesn't just pull the raw binaries. It packages and verifies them in the exact format required by the VCF lifecycle management engine. It ensures that when that package hits the disconnected SDDC manager, the maintenance workflow can trust and process the offline content without any issues.
It standardizes the delivery method for updates.
Precisely.
Okay, so we've established how rigorous VCF is within a single environment. But most large organizations run 2 or more separate VCF environments.
Yeah, dev and prod are different data centers.
Exactly. So if you want a unified operational view, a global view, across these separate VCF instances, how do you connect them?
This requires thinking beyond the single VCF instance and leveraging what's called multi-instance federation.
Yeah.
And you can't get this unified visibility just by linking the vCenters or connecting 2 SDDC managers.
So what's the constraint?
The constraint is networking and security coordination. So the component that provides that global operational view across multiple VCF boundaries is NSX federation.
Ah, of course. It all comes back to NSX.
It has to, because NSX is the mandatory software-defined networking foundation for VCF. Connecting the NSX domains across multiple VCF instances is what enables a global manager to be deployed.
And that manager gives you the single pane of glass.
Yes, that manager then provides the single, unified operational view of networking, security policies, and topology across all the participating VCF instances.
That ties the entire architectural philosophy together. Since NSX is mandatory for every instance, it logically follows that NSX federation is the only way to achieve unified cloud management. You're unifying the network and security plane, not just the compute plane.
Absolutely. It just reinforces the idea that VCF is an integrated stack, and its scaling mechanism has to follow its core design constraints.
That's it for this deep dive into VCF architecture. We hope this gave you a clearer, more profound understanding of the decisions underlying this standardized cloud platform. We'll catch you next time.